In today's session, we are going to talk about drawing graphs for equations in two variables. Now first let's understand what is the meaning of the graph for this particular equation. So the equation given here is 3x minus y is equal to 6. So I basically have to find all points. So let's find all points, or rather a few points that satisfy this particular equation, right? So what I mean by that is, let us find some values of x and y which satisfy this particular equation. So if you take a look at this particular equation very carefully, you will notice that the coefficients of x and y are 3 and minus 1, and the right hand side is equal to 6, right? So 3 and 1 are both factors of 6. So what I can do is, I can now substitute different values for x and see if I can find the value for y. So for example, 3 is a factor of 6. So what will happen if y is equal to 0 in this particular equation? So if y becomes 0, let us now do some rough work. So 3 times x minus, I am substituting y as 0, is equal to 6, which means 3x is equal to 6, which means x is equal to 2. So value of x equal to 2 and value of y equals 0 satisfies this particular equation. Similarly, what will happen if I substitute x as 0? So 3 times 0 minus y is equal to 6. That means 0 minus y is equal to 6, which means y is equal to minus 6. So x is equal to 0 and y equal to minus 6 also satisfies this particular equation. Now let us find if there are some more combinations that can help us. So let's take x equal to 1, right? So if x is equal to 1, then 3 into 1 minus y is equal to 6, which means 3 minus y is equal to 6, which means minus y is equal to 3, transposing 3 to the other side, and hence I can say that y equals minus 3. So when x is equal to 1, I can say that the value of y is minus 3. Similarly, let us take x equal to say minus 1, and let's see what happens to y. So I know that 3 times minus 1 minus y should be equal to 6, because I am basically trying to find all the points that satisfy this equation, and the points that satisfy this equation are going to be the ones which make this equation hold true, right? So minus 3, I can say that minus 3 minus y is therefore equal to 6, and therefore minus y is equal to 9, or y is equal to minus 9. So when x is equal to minus 1, the value of y is going to be minus 9. So now I have a list of 4 points, or rather I have a list of 4 values of x and y that satisfy the given equation. So I can say that this particular point is 2, 0. If you remember, we always mention the x coordinate first and then the y coordinate. And this particular point is 0, minus 6. This particular point is 1, 3. And this particular point is minus 1, minus 9. So let us now plot these 4 points on the graph. 2, 0 is going to be over here. Then 0, minus 6. So x coordinate 0, y coordinate minus 6 is right over here. 1, 3. So 1, 3 you will notice is somewhere over here. Sorry, it's 1, minus 3. If you notice, the y coordinate is minus 3. So this is the incorrect point that we are trying to plot. We want 1, minus 3. So 1 comma minus 3 is somewhere over here, and minus 1 comma minus 9 is going to go out of the graph paper, right? We don't have y equal to minus 9, and hence let us now discard the fourth point, or rather let's keep it, but let's try to find one more point for x and y. Now ideally 2 points are sufficient to draw a line, but just to be sure that my points are correct, I tend to always find 4 points. So over here the fourth point seems to be of no help in the given situation. So let us try to find one more point. What will happen when x is equal to 3? Okay, so let's find what happens when x is 3. So we found that when x is equal to 3, the value of y is also 3. So 3 comma 3 is another point on this particular graph. Now I can definitely join all the 4 points, right? And I get a straight line, if you notice. So this particular straight line is passing through all the 4 points that lie on this particular graph. And hence I can say that this straight line is a collection of all points that satisfy the equation of 3x minus y equal to 6. Hence, I can say that this straight line is the graph of 3x minus y equal to 6. Basically, this line is a collection of all points that satisfy the given equation. So, you can pick any point. For example, do you notice that there is one point which is 4 comma 6. If you notice this particular point, this point has x coordinate 4, y coordinate 6. So let's check if this satisfies the equation. So I have 3x minus y is equal to 6. That is 3 times 4 minus 6 is equal to 6. This is 12 minus 6 equals 6, which means 6 equals 6. And you will notice that 6 equals 6 definitely does satisfy the given equation, right? And this particular straight line is therefore the graph for this particular equation. It basically represents the collection of all points that satisfy the given equation. So let me pause for a minute while you just take a look at all these points and how we found them. Try to understand it and then we continue. One additional question that is asked here is find the points where the graph intersects the x-axis and y-axis. So if you notice where they intersect the x and y-axis, so the graph intersects x-axis at this particular point. The coordinate of the point is 2, 0 at a of 2, 0, and the graph also intersects the y-axis at the point 0, minus 6, at the point B of 0, minus 6. So the x coordinate of this point is 0 because it lies on the y-axis, and the y coordinate is negative 6. Similarly for A lies on the x-axis, so the x coordinate is 2 and the y coordinate is 0. So this is how we plot this particular graph, and we find where the line intersects the x and y axis. So let's move on to the next question now. So let us consider the next question. Draw the graphs for the following equations. 2x plus y is 11, 3x minus 2y is equal to 6, and x minus y is minus 1. So first we need to plot the points for 2x plus y equals 11. Let us first focus on this particular graph. So 2x plus y is equal to 11. So let us now find the points x comma y that satisfy this given equation. So let's consider x and y. I notice that if I substitute x equal to 0, I get, so if I substitute x equals 0, then 2 times 0 plus y is equal to 11, which means 0 plus y is equal to 11, which means y is equal to 11. But you will notice that y equals 11 does not fall in this particular, it does, but it is beyond the scope of our graph right now. So let me just reject this particular point. Let us substitute x as say 3. Okay. So if I substitute x as 3, I get 2 times 3 plus y is equal to 11, which means 6 plus y is equal to 11, and this therefore means y is equal to 5. So when x is equal to 3, the value of y is 5, and therefore the point is going to be 3, 5, x coordinate followed by the y coordinate. Let me now substitute a different value of x. So let me substitute x as 4. So when I substitute x as 4, it becomes 2 times 4 plus y is equal to 11. So this implies 8 plus y is equal to 11, which means the value of y is equal to 3. So I can say that when x is equal to 4, the value of y is 3, and therefore the point is 4, 3. Let's now substitute a different value for x. So let's take x equal to say 2. So 2 times 2 plus y should be equal to 11, which means 4 plus y should be 11, and that implies y should be equal to 7. So you will notice that y equals 7 is definitely a possibility. So I get x equals 2 and y equals 7, and therefore the point is 2, 7. So let us now quickly plot these points on the graph. Okay, we need one more point. Generally, 2 are sufficient, 3 points is good, and 4 points is even better, right? So that we eliminate any possibility of an error. So let's substitute x equals 5 and let's see what happens. So 2 times 5 plus y is equal to 11, which means 10 plus y should be equal to 11, and this implies the value of y should be 1. So when x is equal to 5, the value of y is 1, and therefore the point is 5, 1. Now let's go ahead and plot the graph for this particular line. We know 4 points. So 3, 5 is the first point. So let's plot 3, 5. So 3, 5, this is the first point. Then we have 4, 3. So 4, 3 is the second point. Then we have 2, 7. So 2, 7 is the third point. And 5, 1. So 5, 1 is the fourth point. So now through these 4 points, you will again notice that I can draw a graph, right? Which passes through all these 4 points, and if your points were incorrect, you wouldn't get a straight line. So that is why finding 4 points is always recommended, because then you can check whether you're getting a straight line or not. Now you will notice that the graph passes through many more points which we did not find out. Let me just give you some examples. So take a look at this particular point, the point A here. The coordinate of point A is 5.5, 0. Let's take another point which is right over here. This particular point is say B and the x coordinate is 7, y coordinate is -3. So if you consider these 2 points now, let's see how come they lie on this particular line. So let's see if they satisfy this equation. So let's take the point A. So it is 5.5, 0. So let's substitute x as 5.5. So 2 times 5.5 plus y is 0 is equal to 11. So 2 into 5.5 is 11 plus 0 is equal to 11, which means 11 equals 11, and this holds true. And that is why point A satisfies this equation, which is why it lies on this particular line. Similarly, if you take B, the coordinate of B is 7, -3. So let's substitute 2 times 7 plus of -3 equals 11. 2 times 7 is 14. So 14 minus 3 equals 11. And this equation is also true. And that is why B of 7, -3 lies on this particular line. Now if you pick some other random point, so 1, 1 does not lie on this particular line, right? And the reason for that is 1, 1 will not satisfy this particular equation. So let's try. So 2 times 1 plus 1 is actually equal to 3. And 3 does not satisfy the given equation. 3 equals 11. 3 is not equal to 11, right? So the left hand side came out as 3 and the right hand side is equal to 11. So 11 is therefore not equal to 3, and therefore the point does not satisfy the given equation. And that is why 1, 1, if you notice 1, 1 does not lie on the graph of this particular equation. So I can safely say that only those points which satisfy this particular equation, they lie on the given line. So again, let me pause for a few seconds, take a look at the calculations, and then we move on to our next question. Now let's try the second equation. The second equation is 3x minus 2y equals 6. So we have 3x minus 2y equals 6. 3x minus 2y equals 6. The first thing to check is, will I get good values of x and y if I substitute x as 0? So let's substitute x as 0. Let's substitute x equals 0. Let's see what happens to y. So 3 times 0 minus 2y equals 6, which implies minus 2y is equal to 6, and therefore y equals minus 3. So when x is equal to 0, the value of y is minus 3, and therefore the given point is 0, minus 3. Now let's substitute y as 0. So if you substitute y equals 0, let's see what happens. So you have 3x minus 2 times 0 is equal to 6. Now 2 times 0 is 0, so 3x equals 6. And 3x equals 6 basically implies x is equal to 2. So the value of x is 2 and the value of y is 0, and therefore the point is 2, 0. So if you are super confident of your points, then you can definitely go ahead and plot the points and draw the line. However, just to make sure that we have made no mistake, we need 2 more points. So this time I'm just going to draw the graph with these 2 points because I'm super confident about it. So this is 2, 0, and the other point is 0, -3. So x coordinate 0 means it lies on the y-axis and the y coordinate is -3. So I definitely know that the line is going to pass through these 2 points, right? So let me just draw this particular line. The line should extend on both sides because a line always extends till infinity, right? And this is the line that we have got so far. Now let us find 2 more points just to be sure about what we have done, right? So let us find 2 more points. Now I can substitute, say, x equals 4. So let us now substitute some other value of x. So generally I will give you a nice trick to identify what you should substitute. See, the coefficient of y is 2. So always increase or decrease x by that coefficient. So since the coefficient of y is 2 over here, try to increase the value of x by 2. So let's make x equal to 4. From 2 I have increased x by 2. So it becomes 4. So substitute x as 4. Let us see what happens to y. So 3 times 4 minus 2y is equal to 6, which means 12 minus 2y is equal to 6, and therefore the value of y is 3. So when x is equal to 4, the value of y is 3, and therefore the point is 4, 3, right? So when x is equal to 4, the value of y is 3, and you will notice that we got 1 point on this particular graph, and this point definitely already lies on the graph. So this calculation is right. Now again, let us increase or decrease the value of x by 2. So let's take x equals -2. I have decreased the value of x by 2 from 0. So now let's substitute x as -2 and let's find the value of y. So substitute x as -2, we get 3 times -2 minus 2y is equal to 6, which means -6 minus 2y is equal to 6, and therefore 2y is -12, and therefore the value of y is -6. So when x is equal to -2, the value of y is -6, and hence the point is -2, -6. Let us try to plot that point. When x is -2, the value of y is -6. You will notice that the point already lies on this particular line, right? So now we have got 4 points, and we saw that all these 4 points lie on this particular line, and hence our solution has to be correct. So this is the graph of the given equation 3x minus 2y equals 6. Let me explain the trick that I mentioned right now. See, the equation was 3x minus 2y equals 6. So you are first supposed to find at least 1 point. Find at least 1 point using trial and error method. Find at least 1 point. Either you can try with x equal to 0 or y equal to 0, or maybe if x equal to 0 or y equal to 0 does not work, you can use some other point. After you find 1 point, you change x by the coefficient of y, or you change y by the coefficient of x, right? So over here the coefficient of y was 2, so you can change the value of x by 2, or you could have changed the value of y by the coefficient of x, which is 3. That would have been perfectly fine. So this is how you can solve this particular question. Let me now pause for a minute before I move on. Again, we forgot to mark the scale, and marking the scale should be the topmost priority in graphs. So let me mark that quickly. Let us now mark the graph for the next question. The equation is x minus y equals minus 1. So again, let's check if x equals 0 works. So substitute x as 0. And let's substitute x as 0 in the given equation. So 0 minus y equals minus 1, which means the value of y is equal to 1. So when x is equal to 0, the value of y is 1. Similarly, let us substitute x as 1. So when x is equal to 1, I can substitute 1 minus y equals minus 1, which means minus y is equal to minus 2, and hence the value of y is equal to 2. So when x is equal to 1, the value of y is 2. And when let us substitute x equals minus 1, so when x is equal to minus 1, it is minus 1 minus y is equal to minus 1. Now this minus 1 can transpose to the other side as plus 1. So I get minus y is equal to minus 1 plus 1, which is 0, and hence y is equal to 0. So when x is equal to minus 1, the value of y is 0. And let us substitute x as 2, and let's see what happens. 2y. So 2 minus y equals minus 1, which means minus y is equal to minus 3, or y is equal to 3. So when x is equal to 2, the value of y is 3. And hence my points are 0, 1, 1, 2, minus 1, 0, and 2, 3, right? And let us quickly plot these points. 0, 1 is going to be somewhere over here. 1, 2 is going to be here. Minus 1, 0 is right on the x-axis. And 2, 3. So 2, 3 is going to be over here. X coordinate 2 and y coordinate 3. And now the straight line which passes through all these 4 points is basically the graph of the equation that was given to us. So remember, you should always write the equation on the straight line. So I would write x minus y is equal to minus 1 over here. Again, the scale should have been mentioned. So scale is on x-axis 1 centimeter is 1 unit, and on y-axis also 1 centimeter is 1 unit. So this is how we plot the graphs for the given equations. Pausing for a few seconds before I move on to the next one. Moving on to the next question. Let us consider the following question. Draw the graph for the equation x plus 4y equals 9. So x plus 4y equals 9. This is the given equation. Now first we have to find at least one point which satisfies this equation. See over here, the coefficient of x is 1 and the coefficient of y is 4. So it is much better to find a good value of y and then find the value of x. I will explain it with a reason. Okay. So for example, suppose I took x equals 2. Now if I take x equals 2, I get 2 plus 4y is equal to 9, which means 4y is equal to 7. And y equals 7 by 4, right? Now, I got a fractional value of y because the coefficient of y was 4. And of course, the value of x did not suit for a integral value of y over here. Okay. So, it is recommended that you change the value of y here for the ease of calculations. It would be better to assume y as something because the coefficient of x is anyways 1. So let me now, so one point that we definitely got is x equals 2 and the value of y is 7 by 4. Now we can definitely plot the fractional values, there is no problem as such, but we prefer integral values as compared to the fractional values. The reason for that is, if I want to plot this particular point in decimals, x is equal to 2 and y is equal to 1.75, 7 by 4 is 1.75. So if you try to plot this particular point, x is 2 and y is 1.75. So this is 1.5 and 1.75 will be somewhere over here, right, between 1.5 and 2. But because things might not be very accurate, which is why we prefer not to plot decimal points. Of course, if you have decimal points of 0.5, like 3.5, 4.5 or minus 2.5, then plotting the 0.5 values is much easier. So let me prefer taking integral values of y. Let me take y equals 1 and let's see what happens. So when y is equal to 1, I have x plus 4 times 1 is equal to 9, which means x plus 4 is 9 and therefore x is equal to 5. So when y is equal to 1, the value of x is 5, which means the point is 5, 1. And this is a good point to have. So let's quickly plot it. 5, 1 is right over here. Now, as I mentioned, look at the coefficient of x. The coefficient of x is 1 and change y by that particular value. So let's pick y equals 2 and let's see what happens. So x plus 4 times 2 is equal to 9, which means x plus 8 is equal to 9 or x is equal to 1. So when y is equal to 2, the value of x is 1, right? And therefore the point is 1, 2. So let's plot it. X coordinate 1, y coordinate 2 is going to be right over here. Now of course I'm super confident about my point, so I can go ahead and plot the line. But let me find 2 more points that satisfy this given equation. So again, let me change the value of y by 1. So let me take y equals 3. So when y is equal to 3, let me check what is the value of x. So x plus 4 times 3 is equal to 9, which means x plus 12 is equal to 9, or x is equal to 9 minus 12, x is equal to negative 3. So when the value of y is 3, x is negative 3, and therefore the point is negative 3, 3. So negative 3, 3 is going to lie over here. Similarly, let me take y equals, say, 0. Now if y is equal to 0, let's find the value of x. So x plus 4 times 0 is equal to 9, which means x is equal to 9. But if you notice, I am just in time. I can plot x equals 9 here, and therefore the point is 9, 0, which lies on the x-axis. So this point is definitely acceptable. So when y is equal to 0, x is equal to 9. So the point is 9, 0. So now we can definitely draw a straight line which passes through all these 4 points, right? This particular straight line passes through all the 4 points that we had plotted, and hence this is the equation of the given line. So I will say x plus 4y is equal to 9. Now we have to find the area of the triangle formed by the line with the x and y axis. So what they are basically asking us is, you will notice that with the y axis and the x axis, a triangle is getting formed. We want to find the area of this particular triangle. So this is the triangle whose area we are trying to find. So let us label the vertices. So let this vertex be A, let this vertex be B, and let this vertex be C. So I know that area of a triangle is given by half into base into height. Now over here you will notice that angle P is 90 degree because x and y axis are perpendicular to each other. So I can take BC as the base. So the base is 9 over here. So this is half into 9 multiplied by, now we need to find the height. So if BC is the base, then AB is going to be the height, because the height is always perpendicular to the base. So how can I find the height? What I can do is, A is the point where the graph is intersecting the y-axis, right? So at this particular point, the value of x should be equal to 0. I know that the x coordinate of point A is going to be 0. And the point A lies on this particular line. So A lies on the given line. A lies on the given line, which means that the coordinates of point A satisfy the given equation. And therefore I can say that 0 plus 4y should be equal to 9, which means y equals 9 by 4. So this particular y coordinate is going to be 9 by 4. In decimals, 9 by 4 is 2.25. You will notice that this point is exactly at 2.25. It is between 2 and 2.5. So therefore the height is 9 by 4, and therefore the area of this particular triangle is 81 by 8 square units. This is how I can find the area of this given triangle. Right? So this is how I solve this particular question. One important concept that we learned here is, if you know the equation of the line, you can definitely find the points where the graph intersects the x and y axis. So to find the point where it intersects the x axis, you can simply substitute y equals 0 in the equation. Similarly, to find the point where it intersects the y-axis, you can simply substitute x equals 0 in the given equation, right? Because every point on the x-axis has y equals 0, and every point on the y-axis has its x coordinate equal to 0. So this is how I was able to solve this particular question. Pausing for a minute before moving on. Moving on to the next question. Let us solve this particular question. Draw the graph for the equation 2x plus 3y equals 11. Okay, so let us now find some values of x and y which satisfy this given equation. So can we try x equals 0? So if x equals 0, let's see what happens to y. So 2 times x, that is 2 times 0 plus 3y equals 11, which means the value of y is 11 by 3. Now this is not a very nice point to plot, right? Because it's going to be 3.6 bar, and therefore let us discard this particular point. Let us try y equals 0. So y equals 0 gives me 2x plus 3 times 0 is equal to 11, which means the value of 2x is equal to 11, and therefore x equals 5.5. 11 by 2 is 5.5, and that seems to be a very good point to plot. So 5.5, x coordinate of 5.5 is right over here, right? And this particular point is therefore my first point. So let me enter this in the table. When x is equal to 5.5, the value of y is 0, and hence the point is 5.5, 0. Now let us increase the value of y by the coefficient of x. So what is the coefficient of x? So in 2x plus 3y equals 11, the coefficient of x is 2. So let us change the value of y. Let us change the value of y by the coefficient of x. So coefficient of x is 2. So let's change it by 2. That means let's take y equals 2. So if y is equal to 2, let's find what happens. 2x plus 3 times 2 is equal to 11, which means 2x plus 6 is 11, and therefore 2x is 5, which means x is 2.5. So this implies x is equal to 2.5. So when the value of y is 2, x is 2.5. So let's plot that point. X is 2, y is 2.5. So 2.5 is going to be right over here. So this particular point is x equals 2 and y equals 2.5. So this particular point is 2.5, 2. Now again let us take y equals 4 and let's find what happens to x. So 2x plus 3 times 4 is equal to 11, which means 2x plus 12 is 11, which means 2x is 11 minus 12 is minus 1, and therefore x is minus 0.5. So when y is equal to 4, x is minus 0.5, and hence the coordinate is minus 0.5, 4. So let us quickly plot this point also. Minus 0.5 is right over here, and 4. So we are talking about this particular point. So let me erase the 4 that was written here. And the point is right over here, minus 0.5, 4. This is the third point. And now we want to find the fourth point. So let us take y equals minus 2. So instead of increasing it by 2, now from 0 I have decreased it by 2. Let's see what happens. So I get 2x plus 3 times minus 2 is equal to 11. And therefore 2x minus 6 equals 11. So 2x equals 17, which means x is equal to 8.5. So when x is equal to minus 2, the value of x is 8.5. When y is minus 2, the value of x is 8.5. And this is how we get these 4 points. Let us see if they form a line. If they form a line, or if they lie on the same line, it means that our plotting is extremely accurate. So you will notice that the graph is passing through 3 points, but it is not passing through one of the points, right? So now we need to investigate why is it not passing through this particular point. So this particular point happens to be 2.5, 2, and you will notice that I plotted the point incorrectly. This particular point is actually 2, 2.5. Whereas 2.5, 2 should have actually been this particular point. So this particular point is 2.5, 2. So 2.5, 2 is correctly lying on this particular graph, and 2, 2.5 is not. So this is an example that when I plot the points incorrectly, somehow they do not fall on this particular straight line. And this is how you can catch your mistake when it comes to plotting a straight line. And this is why plotting 4 points is essential. So you must have noticed that if I was super confident about my first 2 points, I would go ahead and with incorrect plotting of points, I would get a very different line than as compared to the right answer. So that is why when you have 4 points, you can actually check whether your answer is very accurate, and that is why plotting 4 points is definitely recommended. So again, let me pause for a few seconds before I move on. Now we have only partially solved a question. We have solved a question for drawing the graph. We are yet to solve the problem for the next two subparts that are given. So after a few seconds, we will solve those subparts as well. So let us solve the next two parts. Find the value of y when x is equal to 4. So we can do that using two methods. First, let us use the graphical method. When x is equal to 4, so x is equal to 4 right over here, right? When x is 4, the value of y is 1. If you notice, the point is 4 comma 1. So when x is equal to 4, the value of y is 1. Also find the value of x when y equals 5. So y equals 5 is right over here. So when y is equal to 5, I am at this particular point on the line. So x is equal to minus 2 when the value of y is 5. So when y is equal to 5, the value of x is minus 2. So basically what we are doing is we are trying to find that particular point on the graph when x is equal to 4, and that happens to be the point A, and that particular point on the graph when y is equal to 5. So y equals 5 means it is this horizontal line, and that happens to be point B. So point B is minus 2 comma 5, right? So points A and B are those values when x equals 4 and y equals 5. Now this is the graphical way of finding it. There is an algebraic way of also finding it. So to find y when x equals 4, what I can do is I can substitute x as 4 in this equation. So 2 times 4 plus 3y is equal to 11, which means 8 plus 3y is equal to 11, or rather 3y is equal to 3, and therefore y equals 1. So when x is equal to 4, the value of y is equal to 1. Similarly, I want to find the value of x when y equals 5. So when y is equal to 5, take y equal to 5, we get 2x plus 3 times 5 is equal to 11, which means 2x plus 15 is equal to 11, or 2x is equal to 11 minus 15 is minus 4, and therefore x is minus 2. So the value of y, when y is equal to 5, the value of x is equal to minus 2. This is how we can solve this particular question using the graphical way or using the algebraic way. So in this session, we did plot a few graphs, and we also tried to find area of a triangle. We also found the values of the coordinates where the graphs intersected the x and y axis, and also you will notice that in this question specifically we found the values of y and x when the other variable was given, and we end our today's session over here. I hope you understood the questions that were solved in today's session. So pausing for a minute, and then we end today's session here. ending today's session here.